Welcome back, everybody. It's the last part of this last section here. To try to finish up, we're going to talk about one-sided limits, and then we're actually going to get into the very first thing you use a limit for in terms of a calculus concept that is really a little bit algebra-based stuff. Okay, so one-sided limits is exactly this. If you remember back in the other previous videos, we talked about a limit does not exist when it doesn't exist, and one of the times is if it approaches one number from the left and one number from the right, different numbers, then it doesn't exist. So, and I even made a comment then that we're going to look at that we can actually still look at the limits from the right side and the left side. Okay, yeah, they don't approach the same number, but there's a limit on the one side and there's a limit on the other side. It kind of gives us an idea about what's going on with the graph. So we have a little bit of notation. It's real simple. We say the limit as x approaches c with and instead of an exponent, we're going to put a plus symbol in the exponent. That means this plus here means from the right side. Okay? And then if I want the left side, I'm going to put the exponent as a negative, and that means the left side. Okay? So that's what the notation means. So what does that look like in a problem? And most of the time, we can't really do this from an algebraic standpoint. We're going to do it from a graphing standpoint. And again, and this graph is missing some open circles. So here's what the equation, or the problem says. It says limit as x approaches 0 from the left of 2x over x, absolute value of 2x over x. Over here, then this other one is as x approaches 0 from the right of that same function. So on the left, here's my left, here's 0, right? Here, this line right here is 0. And as I approach it on the left, what number am I approaching, or am I always in this case? Well, in this case, that is equal to negative 2. And then this one's on the right. As I approach from the right, what am I approaching? And in this case, that is, I'll put it up here, 2. Okay, so that's the idea. You're going to look at two different limits here. Maybe this one will make a little more sense. Okay, now, I'm going to show you how to do this one both ways. One by the graph and two without the graph. All right, so let's look at the graph first of all, this piecewise function. We're going to look at it, as you can see, x approaches 2 from the right, 2 from the left. So let's look at the graph here. What would the graph look like? All right. 1, 2, 3, 4. 1, 2, 2. Okay, so I'm actually going to graph the bottom one first. X squared when x is less than 2. X squared is a parabola. Has a point there, has a point at negative 1, 1, and at 2, 4, and then at 1, 1. And then at 2, it's going to be up at 4 as well. Okay, but it's going to be, I'm sorry, 2, that's at 4. And it's going to look like this. Okay, and this goes on, of course. Okay, so that's what this part looks like. We have an open circle there. X plus 2 would be a graph. Let's see, normally, well, we've talked about how to do this before. We could go at 2 and plug in, and it's going to be at 4. It's actually going to be a closed circle there. But at 3, I'm going to be at 5. At 4, I'm going to be at 6. So it's going to be a line like that. Okay? All right, make sense? All right, kind of look like that. Don't worry, you're not going to have to graph these. I'm going to show you another way to do it. So if we look at this, we want to find f of x as it approaches 2 from the right. That would be this direction. Okay? If we notice, we're going towards 4 in this case. All right? If I go from the left, I'm also going to 4. Okay? We're going to come back to that. Okay? Now, how could I do this algebraically? Well, if I want to go from 2 from the right, we can use direct substitution. Which side is the right side of 2? Well, x greater than. So I could just plug in, I could go 2 plus 2 and get my 4. And then the left side would be everything on the less than x. So again, I could just plug into that one, 2 squared, and that equals 4. So you can use the piecewise and use the fact that it says greater or less than. It doesn't really matter, it's equal to. Okay, and so if I want the left I want the one less than that number, and that's where I'm going to plug in. If I want the right, I'm going to plug into the one that's greater than. All right. Now, something special happened here. They both are equal to 4. That means if I were to bring this all together, the limit as x approaches 2 of f of x, since they both are the same, that means the overall does have a limit of 4. If I would have gotten two different answers, there wouldn't be an overall limit. So that brings us to kind of like this final definition of the limit as x approaches c of f of x equals L, if and only if the right-hand limit is L and the left-hand limit is L. If they're both equal to the same thing, then the overall limit is the same. I don't think I'm going to get into it, but normally I spend a lot more time on these piecewise ones. You're going to do it more next year in Calc and really hit this home. So I'm just going to kind of glance over it and do a couple problems with it. Hopefully you can just use that direct substitution on it. Okay? All right. Now, the last part is the part that deals with calculus. There's a limit in calculus that we're going to look at. We're going to look at a couple examples here. Okay, 2 in particular. All right, so here's the difference quotient. You don't have to memorize this. It's going to be given to you in problems. It says limit as h approaches 0 of f of x plus h minus f of x all over h. You're going to do tons of these things. Okay, I had to pause there. Sorry for a moment. All right, you're going to do tons of this next year in Calc. Formula might look a little bit different, but it's the same concept. All right, so let's break this down a little bit. There's a lot of algebra going on here. The actual limit portion of it is relatively simple, but the algebra is a little more involved. So here's what we have to do. We have to first find this. Okay, well, how do I do that? Well, I'm going to plug that in for that. So it looks like this. All right, now we got to work that out. Remember, this means this. Right? We have to FOIL that out. I'm going to do it this way so I have some more space because I'm going to need a lot of room for these. So this is x squared. We get an xh and an xh, so that's 2xh plus h squared. And then we still have minus 1. So there's my f of x plus h. So now, I'm going to figure this part out. We're going to do a lot of algebra before we get to the actual limit portion. All right, so this is this. We're going to put it in. X squared plus 2xh plus h squared minus 1. Minus, now it says f of x. Well, that's right there. That's f of x. I'm going to put parentheses around it because I got to distribute that negative, and it's all over h. Okay. Let's scroll this up just a bit. Okay. So now we need to distribute that negative. So here's what I get. I'm actually going to take little steps instead of trying to combine. Minus x squared plus 1 all over h. Now, what should happen is some things should cancel. All right, so what should cancel? The x squareds cancel and the 1. What should happen is anything that does not have an h in it should cancel if you did it right. All right, so then we're left with that. Well, we got one more step of simplifying before we get to the actual limit portion. All right, so what does that look like? Well, this, remember, we could break it up, right? We could do this. We could say 2xh all over h plus h squared over h. Well, what does that give me? Well, the h's cancel here. I get 2x. H squared over h is just h. All right, so we've simplified that. Now we have to take the limit. So we're going to, because remember, what we want to do is take the limit of this thing. Well, this is that answer. So what we're asked to do is the limit as h approaches 0 of 2x plus h. Plug in my 0, so that's 2x plus 0. So my answer is 2x. You are not going to get an answer like a number or that kind of thing. Okay, you're going to get an equation of sorts because this thing called the difference quotient is important. It has something to do with calculus and working with that equation. It is connected. This answer is connected to the original function here. Okay, so you're going to get values like that. But it's a lot of algebra. It's a great thing here. I know at the end of the year, in our situation, this is a little challenging. But it always is a little bit for students because there's a lot going on here. Okay? All right. I think we'll try one more, probably a little more complicated one. Okay, there's your limit you want to find. So again, first thing we need to find is this. And maybe you guys want to try this one on your own first. You can pause it and try it. So that. And that. Remember, that one actually means this. Oops, that's an H. All right. So this is x squared plus 2xh plus h squared plus 2x plus 2h minus 3. Nothing simplifies. All I did to get that 2x plus 2h is distributed. So there's my f of x part. So now we have to figure this thing out. And so we're going to put that in. Plus h squared plus 2x plus 2h minus 3. Subtract. Remember, this is all over h. Subtract the function of x squared plus 2x minus 3. Sometimes, especially when these longer ones, I do some things to help me out here. So I'm going to distribute the negative. So of course, this becomes a minus, this becomes a minus, and this becomes a positive. So that x squareds cancel. 2x cancels and the 3 cancels. Okay, it just saves you some time in writing. All right, so what do we end up with? We end up with 2xh plus h squared plus 2h all over h. Now, what we can do here is, you can separate this, but really what's happening is h is going to divide into each of these terms. So h into this one gets me 2x, h into this gives me h, h into that gives me 2. So then, what I'm taking as limit as h approaches 0 of 2x plus h plus 2, I would get 2x plus 0 plus 2, so my answer is 2x plus 2. Again, you're going to get something like an equation back for the answer. Okay? All right, I know they're a little complicated. Check them out. Maybe rewatch that section. Use this written down if you have to, or look at the picture or whatever, and try to work out a few of those. Okay? All right. Good luck.